Hello, this is Mr. Henry, and welcome to lesson 1.3. Today we're going to write expressions. So the essential question says, how do I translate verbal phrases into expressions? So basically we're going to be taking word problems and changing them into math problems. We do have two get the goofs here, so let's see how they go. Number one, evaluate this expression when x equals 5. So everywhere we see an x, come on marker, everywhere we see an x, we'd plug in 5. So that piece right there would be a 5. Okay, so the first step is good. And then when we follow the order of operations, the next thing we should do would be, see, there's no more parentheses, exponents. We would do this 5 squared next. So the rest of this is wrong. So we should have a 3 plus 4 and 5 squared. 5 times 5 is 25. Alright, so we have no more parentheses, no more exponents, multiplies and divides. This is a multiply. So that gives us 100. And one thing left to do, add it up, 103. Number 2, we've got a subtract, an add, and a multiply. The order of operations says that we're going to multiply before adds and subtracts. So that part gives us 6. First step, good. Alright, so from here down, so there's no parentheses, no exponents, no multiplies or divides. There are adds and subtracts. So they did the, I have no clue what they did. Oh, they did this subtract, or this, I don't know. What you should do is you should do the subtraction first. Because when you have adding and subtracting in the same step, you do whichever comes first, the left one first, which is that one. So you take 25 minus 10 is 15. And then 15 plus 6 gives you 21. Okay, so that's order of operations. We have a couple vocabulary words here today. We've got verbal model, which is going to be used a lot. A verbal model describes a real-world situation using math symbols. So you'll see a lot of times a verbal model is basically an in-between step between the word problem they give you and the math problem you need. So, for example, if the word problem says James had 3 more jelly beans, I might put something like jelly beans plus 3. Well, this is not an actual math expression yet. We would eventually change that down to like maybe j plus 3. But the verbal model helps you get all your thoughts down and make sure it looks good before you go through and make it into a complete expression. The rate and unit rate we will be using throughout the lesson. A rate is a fraction that compares two quantities in different units. So you could say, like students to teachers, or like miles per hours, dollars per soda. And a unit rate, so unit rate, verbal model, there we go. A unit rate is a rate with a denominator of 1. So in the other example I said like, if you said like $5 for 3 sodas, a unit rate of that would be how many dollars for 1 soda, where you're always trying to figure out how much for 1. Now before we get into really doing a bunch of these problems, you'll see on the note sheet there's this place here where it says key phrases, and I give you some add, subtract, multiply, divide, a section for each. Because we're talking about word problems, it's very good to know what key phrases let you know that this is an addition problem, or let you know that it's a subtraction problem. Okay, so what we're going to do is just go through and kind of list out some of these key phrases that we have here. And I encourage you to actually pause the video right now, write out all the key phrases that you know of. It'll help refresh your memory a little bit. And then hit play on the video, and we'll go through it together, and then you can fill in any ones you missed and you might even have a couple extra. So go ahead, pause the video, do that now, and then hit play when you're ready. Alright, so here's the ones that I came up with. For addition, sum, I spelled that wrong already, plus, total, more than, increased by. That's really all I have for addition. Subtraction, I have difference, less than, minus, decreased by. This one's kind of funky. We'll have to watch out for him. Multiplication, we've got times, we've got product, we've got multiplied by, actually here I guess you could say subtracted from, you can say added to, multiplied by, of. That's one word that you guys probably don't have. The word of in math almost always means multiply. If I said 25% of 36, you're going to change this guy to a decimal, multiply by 36, and that gives you your answer. So of means multiply. And also words like twice. If you do something twice, you're doing it 2 times. And for division, we've got quotient, we've got divided by, divided into, cut into. Anytime you have a problem where you're cutting something up into equal pieces, like if you have a pizza and you're cutting it into 5 equal pieces, you're dividing it. Or if you have a rope and you're trying to cut it into pieces that are each 3 inches long, that's dividing. That's also one that you'll see quite a bit. It's kind of a hidden division, but when you're cutting something up, if you're cutting it in equal pieces, that's division. Okay? So now we have a nice list of words here to help us keep track of which ones are addition, subtraction, multiply, and divide. So let's go through and look at some of our word problems. So here we have example 1. Just wants us to translate the verbal phrase into expressions. So example A here says the product of 3 and a number. You notice we don't actually have to do this math. We just need to change it to a math problem. So we're looking for those key phrases. Product means we're going to multiply. So the multiplication of 3 and a number. Now here it doesn't say what number. We're not just going to make up something and go, oh, 3 times 5. No, that's not what we're going to do. When you see the phrase a number, that's like code word for variable. This is a number that we don't know what it is, so we're going to put in some variable. How about n for number? So here I have 3n. Letter B. 3 times the sum. So I have a 3 multiply. And I'll write underneath 3 multiply the sum, which is an addition of 7 and a number y. Now, if I leave it like this, it looks kind of stupid. I mean, you don't say 3 times plus 7y. That doesn't make much sense. So it's definitely 3 times, and then the sum of 7 and y. So this sum, I'm actually adding these two things together. And then when I take 3 times this stuff, we actually need it in parentheses. So the final way we'd write this would be 3 times. Now you could put your multiply symbol in there if you'd like. So 3 times the sum of 7 plus y. That's what this looks like. 3 times the sum of 7 plus y. Okay? Now I have 2 problems I'd like you to do, letters C and D. So copy them down on your paper. Write them as a expression. and then hit play and we'll go back together. Okay, letter C. It says the difference of 35 and twice the number m. So you're finding the difference of something, which is subtraction. So you're subtracting 35 and twice the number m. Now, what the heck does that mean? If you're having twice the number m, that means you're having that thing 2 times, like that. The difference of 35 and twice the number m. 2 m's. Quotient, divide, of a number k and 2 plus 19. So the quotient of a number k, so I'm dividing k and 2 plus 19. The quotient of a number k and 2 plus 19. So that is how you're changing these word problems into expressions. Now, not every word problem is going to be exactly like this, where they just give you those keywords right out. Some of them are going to be a little, well, like a little story, like this one, example 2. It says, you and 4 friends go to a restaurant for dinner. Everyone ordered the nightly special. Write an expression for the total cost of the meals. One thing you'll notice you're missing. It doesn't say how much the nightly special costs. You cannot actually find the answer. That's not the goal. The goal here is to write an expression to find the cost of the dinner, whatever the cost of the nightly special is. So, for example, let's see. Well, how many people ordered this dinner? It wasn't 4, it's 5. You and 4 friends. So there's 5 people who ordered the same meal. So 5 times this nightly special. This is our verbal model. It starts from here. We have our big long word problem. We break it down into just the most important information, but it's still easy to understand. 5 times this nightly special because we have 5 of them. The last step is our actual expression, where instead of using words, we just use a variable. So 5 times m, maybe, for meal. Or you could also say 5m. These are the same. 5 times m or 5m. So this would be our expression. 5 times m or 5m. It's either one's the same. So word problem, verbal model, kind of gets you in the right direction, and then expression. Okay, let's try letter B here. It says Sam just paid $103 for his phone bill from his bank account. Write an expression for the amount of money left in his bank account. Again, you'd think, okay, so you'd take your bank account minus $103 gives you whatever's left. That would make sense to me. That's how I'd figure it out. Like if I was paying for something out of my wallet, I'd take the money in my wallet minus $103, and that's how much money I have left. Well, we don't know how much money he has in his bank account. So that mystery piece here is going to be our variable. So let's use like a b, minus 103. So now we know that if he had like $1,000 in his bank account, we take 1,000 minus 103. If he had $26 in his bank account, we take 26 minus 103, and this guy's in trouble because he has negative money in his bank account, and they'll be looking for some money soon. All right? So, verbal model just gets you those ideas down on paper. Using words if you need to. It doesn't have to be all words. You don't have to write sentences. It just kind of helps you organize your thoughts. Okay, letter C. I'd like you to try this one. It says you have a piece of ribbon that needs cut into 6 pieces. Write an expression for the size of each piece. Pause the video, do this problem on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, so what you should have saw, or you should have done, the verbal model that I would use is I would say you take your ribbon and you need to cut it into 6 pieces. So you are dividing it into 6 pieces. So this is our verbal model. We don't know how big the ribbon is to begin with, so the ribbon divided by 6, that gives you how big each piece is. There's your ribbon. 1, 2, 1, 2, 3, 4, 5. Yeah, there's my 6 pieces. So I'm dividing it by 6. All right. So let's move on to our unit rates. So when we're finding these rates and unit rates, first off, a rate is kind of like, you can write it as a fraction. Okay. It's comparing to things, like I said, like miles per hour or student to teacher. Those are all kind of things we could use as rates. So here we have a car travels 140 miles in 2 hours. The first thing I'm going to do is I'm going to write that thing as a rate. So I'm going to put it as 140 miles in 2 hours. One thing that is extremely important here, folks, is you've got to include your labels. Do not forget your labels when you're doing this. Now, there are a couple different ways we can do this problem. We know that a unit rate, which is what we're trying to find, a unit rate has a denominator of 1. So you'll look at the rate we have here. It does not have a denominator of 1. The unit rate we're going to make does have a denominator of 1. Now, I mentioned there's a couple different ways to do this. There is. If you remember how to solve proportions using cross multiplication, that is one way to do this problem. You can take 1 times 140, 2 times the variable, divide by 2 on both sides, and your missing piece will equal 70. I'm telling you right now, the answer there is 70. That's one way to do it. If you know how to do proportions, you can do it that way. We're not going to do it that way just yet. I'm going to show you another way to do it, and then you can decide for yourself which way you like better. Another way to do this is when we're writing our unit rate, let me see if I can move this guy over a little bit. Nice. When we're finding our unit rate, if you just honestly take this guy and pop it into a calculator and divide. So if you take 140 divided by 2, it will give you your new numerator. Say, why does that work? Well, if you take the top and bottom, divide by 2. 2 divided by 2 is 1. That's what we wanted. That's a unit rate. 140 divided by 2 is our new top number, which, believe it or not, is 70. So using a calculator, if you take the 140, the numerator, divide by the denominator, you will get that number over 1. Or, if you like cross multiplying, you can cross multiply because this is a proportion, and you can solve it that way too. I'll be honest, my favorite method is proportion, especially if you have a calculator handy. Letter B. It says it costs $2 for an 8-ounce soda. So the unit rate would be, well, if we have $2 for 8 ounces, we want to know how much is it for 1 ounce. Notice how I have my labels. I have my missing piece. I'm going to call it a variable for now, because that's what a variable is. It represents a number that we don't know the number is yet. Now, I'm going to cross multiply because I like it. So I'm going to take 1 times 2 is 2. 8 times x is 8x. That's not an 8. That's an 8. Do I have space over here? I do. All right. And then I'm going to divide both sides by 8. These cancel out. X equals. And do you know what 2 divided by 8 is? I do, but I'll show. 2 divide 8 equals 0.25. So my missing piece, my x, is 0.25. So my unit rate was, it is 25 cents. See, because this was dollars, my label, 25 cents for 1 ounce. That's how to do it using a proportion. This is how to do it using just division. Both of them are perfectly good ways to do it. You do it the way you like best. Speaking of you doing problems, you've got letters C and D to do right now. Copy them down, pause the video, do them on your own. When you're ready to continue, hit play, and we'll go through them together. Okay, you should be done, so let's see what we got here. Can I move? Nice. Letter C, 2 gallons of paint used for 9 walls. So 2 gallons of paint, see my label, gallons of paint, for 9 walls. And the unit rate would be how many gallons of paint for 1 wall. The denominator is always 1. That's what a unit rate means. Now, I'm going to do this using the other method, the divide method. So I'm going to take divide by 9 here, divide by 9 there. So I'm going to divide by 9 top and bottom. So 9 divided by 9 is 1. 2 divided by 9, 2 divided by 9 is 0.222222222222222 repeated forever. So 0.2 gallons of paint for 1 wall. That's our unit rate. Letter D. 9 slices of ham. Now, you don't have to use 2 letters like I'm doing. Maybe you want to just use 9H for ham. So you need 9 ham for 3 sandwiches. And as a unit rate, you want 1 sandwich. So I need to know how much ham. Proportion would work out nice and pretty here, or actually this one does work out nice just doing it the divide way, because watch, divide by 3. 3 divided by 3 is 1. 9 divided by 3, hopefully you can do that in your head, is 3. Now let's see if that makes sense. If you got 9 slices of ham for 3 sandwiches, so there's 1 sandwich, 2 sandwich, 3 sandwich. There, those are H's. That's all my ham. So there's 3 sandwiches, and each sandwich has 3 slices of ham. So 1 sandwich has 3 hams. Those are unit rates. Now, the next example we're going to see is an application of unit rate. It's kind of long, kind of complicated, but it's not that bad once you actually start thinking about it. So let's read it first. We'll talk through it together, work through it together, and then you'll have one similar to do after the fact. It says here, you have a club membership in a local ski club. The membership costs you $40 per month, which includes 10 lift passes. Okay, so if you're thinking about what's the important information here, first part is really not that important. This is garbage. Membership costs $40. Sounds important. Oh, $40 per month. That sounds important. Which includes 10 lift passes. Maybe important. You must pay a fee for each lift pass after the 10th. Okay. 2 months ago, you paid $13.50 for 3 extra lift passes. Find your total cost for last month if you bought 7 extra lift passes. Now, what that means is my total cost, so here's my verbal model. My total cost is my membership plus extra lifts. Extra TRA passes. So that's all the stuff you have to pay for. You'd have to pay for your membership costs, which includes 10 lift passes, and then any extra passes for using the lift. So that's my verbal model. This is helping me get my ideas down in sort of words. Now, we know the membership costs you $40. It says so right there in the problem. Membership costs $40 per month. Got it. Now, we do not know how much 7 extra passes will be. We know how much 3 extra passes are, but we don't know how much 7 extra passes are. So watch what we can do. We can actually use this unit rate stuff to find this. So we're going to put this on hold for a second, and we're going to find out how much it costs for each extra lift pass. Because it says it costs $13.50 for 3 passes. Well, how much does it cost for 1 pass? Because if we know how much it costs for 1 of them, we can find out how much it costs for 7 of them. So take this, divide by 3. Take this, divide by 3, and calculator says we're going to take $13.50, divide by 3, $4.50. So each extra lift pass cost me $4.50. That means if I get 7 extra, I have to pay that $4.50 7 times. And that would give me my total membership cost. I'm going to pause right here and talk through what I've done one more time just to make sure you're understanding where I'm coming from and why I have this stuff here. So, in the problem, it says membership costs $40 per month, and then after you've used up your given lift passes, it costs you extra. It says 2 months ago you paid $13.50 for 3 extra passes. And they want us to find the total cost for the month if you bought 7 passes. So the verbal model was the total cost is your membership plus 7 extra passes. We knew the membership cost $40, but we did not know how much 7 extra passes cost. Using our unit rate, we know that $13.50 is the cost for 3 extra passes. So $13.50 for 3 passes. How much is it for 1 pass? We found the unit rate, and we found it was $4.50 for 1 pass. Which means all we have to do now is take that $4.50 times by 7, and that gives us how much those extra passes cost. So let's do that. I'm going to erase this piece down here and finish up the problem. So I need to take my 7 times my $4.50. That gives me $31.50 plus 40 gives us our total. Add those two things together and you get $71.50 is your total cost. And we should probably put some dollars in front there. So a unit rate is very good if you're trying to compare things that don't really compare. Like here's 3 extra passes, and we know how many for 7. Well, if you could find how much it costs for 1 pass, then you can multiply that 1 pass times whatever you want. Here's another multi-step problem. This is letter B. This is for you to try. It says a recipe you are making calls for 1 cup of milk and half a cup of vegetable oil. If you are making this recipe for 5 people, what would be the combined total of milk and oil in this recipe? Go ahead, pause the video, do the problem right now, and then hit play. We'll get back together in just a second. Okay, so 1 cup of milk, half a cup of vegetable oil for 1 person. Well, if we're making this for 5 people, we need to take each of these things times by 5. So I need my milk times by 5 plus my oil times by 5 equals the total. It says the combined total of milk and oil. So that gives us the total. So I need 5 times the amount of milk, 5 times the amount of oil. Okay. Well, milk was 1 cup times by 5. Oil is half a cup times by 5, giving us our total. That total is 5 cups. That's easy. 1/2 times by 5. And if you don't have a fancy calculator, if you got one of these inky dinky calculators like me, 1/2, if you don't know what that is as a decimal, 1 divide 2, then take it times by 5, so you got 2.5. So the total amount of milk and oil combined together, if you add those pieces together, is 7.5 cups total. Now, this whole problem could be done another way. You could take your 1 cup of milk plus your 1/2 cup of oil, giving you 1.5, and then take that whole thing times by 5, and you get 7.5 cups again. Now, this way looks smaller. I didn't write out as many steps. I didn't write out like the verbal model and all the other stuff. So it would take up just as much space. It's just another way of doing the problem. Okay. It looks like you have 2 problems to do out of the textbook. These come from page 15. There's number 1. Page 17, number 4. Go ahead, pause the video, do these 2 problems on your own right now, and then we're done with the lesson. Okay. It says here, translate the phrase, the quotient when the quantity 10 plus a number x is divided by 2 into an expression. Okay, so we want to translate this into an expression. All right. So the quotient, which is division, when the quantity 10 plus a number x is divided by 2. So what I'm imagining in my head is I have this 10 plus a number x being divided by 2. So 10 plus a number x is being divided by 2. The quotient, which is a division, I'm doing a division, when the quantity 10 plus a number x is divided by 2. Now, one thing you guys may not know is when you see the phrase the quantity, that is actually parentheses. If I said 4 times the quantity x plus 3, 4 times the quantity x plus 3. So the quantity is a key phrase for put parentheses around this next piece, and then divided by 2. So you could also write this as 10 plus x with your parentheses divided by 2 like that. Both of these are the same thing. Number 4. Suppose your friends share cell phone service. Okay. They pay a basic charge of $35 and $88.80 for 40 extra minutes. Find their total bill if they use 35 extra minutes. Alright, so the total bill is what? What do they have to pay for? They have to pay the $35, so the basic charge, plus extra minutes. And in this problem, they paid for 35 extra minutes. Now, I know the basic charge is $35 from there, but it says they paid $8.80 for 40 extra minutes. We want 35 extra minutes. So this is where that unit rate thing comes in again, because if we can find out how much it costs for 1 minute, we take that thing times by 35, and we've got the cost of 35 minutes. So over here, $8.80 for 40 minutes, and we want to know, and that's my labels, and we want to know how much it is for 1 minute. So you divide by 40, divide by 40, $8.80 divided by 40 is 22 cents. So now I know it's 35 extra minutes times by 22 cents a minute, and 35 times by 0.22 equals, that's not right, I messed up something. 35 times by 0.22, I messed up again. 35 times by 0.22, got it, is 7.7. That's 7, not a 2. 7.7 plus the 35 gives us our total. And we add those things together, and we are going to get a $42.70. And we're done. So we had our verbal model. We changed that into an expression. The piece we did not know is we did not know how much it cost for 35 extra minutes. But using a unit rate of this, we took this rate and turned it into a unit rate, we found the cost of 1 minute. 1 minute times by 35 is the cost of 35 minutes. Added the two pieces together and got our total bill of $42.70. So, the summary question asks you, how do you write an expression to represent a real-world situation? See if you can put down an idea. This one's a bit more abstract, but how do you write an expression for these real-world situations? Pause the video, do it on your own. When you have an answer, hit play. We'll go through it together. This is what I came up with. I have here, you set up a verbal model to organize your thoughts. Then plug in the values from the word problem, and then you would it just asks you to write it. So there, we wrote it. And then what you'd do is you'd evaluate after that. You'd solve and get the answer. Here is your homework. It comes from page 18 of the textbook. Numbers 2 through 8, 13 through 18, 22 through 25, and 31. And you'll see 31 is actually on page 19. This has been lesson 1.3. Thank you for watching.